Hello, welcome to my YouTube channel. So today I am going to explain this problem. What forces round 890 if to C to become max. I have recently solved this problem. I have solved this problem. So let's go with the problem. That what is splitting and what we need to do in this problem. Okay. So first of all, let's let's check that what are our inputs and what we need to output problem. So we have three test cases. C is 100, okay, and then just NNK. So N is out to 1000 and K is up to 10 power 8. The length of the array A and the maximum number of operations that can be performed. Okay, so there are a number of operations we need to perform. Number is K, and we have integer N. So what N is denoting? That the length of the array A. So the second line we need to take input of all array. So A of size N. So okay, input part is completed. Then what is our output? So what we need to uh, output. So for each test case, output will be a single integer, the maximum of array after performing at most k operations. So first of all, we need to understand that what this operation is doing. So it is mentioned in the question. So let's move to the question. What is our problem statement? So you are given an array of integers a of length. So I have an array of the size n. Okay. So there is a constant of a ai will be 1 to 10 power 8. Okay. So in one operation, what can I do? That I can choose any index I, which will be 1 to n minus 1, and ai less than equals to ai plus 1. Okay. So what can we do if this condition matches? So we can increase our ai by 1. Okay. So so this is the operation. This is one operation. So we have to find the maximum possible value of ai that I can get after performing the operations at most k times. So for example, I am going with small example. Suppose I have two. This is my array. Okay. So what would be my maximum integer after one operation? That will be 2 and 1. It is understandable. And after one operation again, so I cannot do any operation here, because if I choose, so here I am allowed to choose only this index. Okay, and it is not validating my condition, so I cannot include this, so this would stop. If I have some array like this, so in one operation, what it could be that 2 1 1. Okay, in another operation it could be 2 2 1, right? Because I can include this one. In first operation, you can also include any of these two first. Okay. So in the one, the first, second, in the third operation, what we can do that we can do 3, 2, 1. Uh, and after third operation, we cannot do any operation, right? Because they are not, there don't exist any value like this. It is pretty fine to understand that what is the condition is saying. So let's understand what we need to find. So we are given a value k. So we are allowed to do k operations by which we can achieve some new array. Out of them, we need to return that what is the maximum possible maximum here. Okay. So it is understandable. I think it is understandable what is the question means. So let's analyze our test cases that how we can achieve the problem. So for the first test case, let's see. So let's take a big example. So that will be fine. 5, 6, 1, 3, 4, 5, 1. So, okay. So we are allowed to do 6 operations. So in every operations, we try to maximize our maximum value of the array, right? So in the first operation, what should I use? First operation. So I'm saying that so what can be increasable? What of the increment that can be increased? So it is this one can be increased. This one also can be increased. This one also can be increased. So what should I do? That I will increase this one, 1, 3, 5, 5, 1. Okay. This is the after first operation. After second operation, what do I will try to increase? I will increase this one. Okay. This will be 1, 3. That will be 6, 5, 1. Okay. So now let's check what are the elements that can be increasable, that can be increased. So this integer which was previously can be increased, but now it is to its maximum limit. It cannot be increased more than 6. Okay, but these two integers we can increase. We have done only two operations. Okay, so after one operations again, what will be my array that I will 3 to 4. Okay, let's 1, 4, 6, 5, 1, right? So let's increase again. 1, the 1 will be the value that will be 5. So everything will be same. Okay, it is right. How many steps we have done? 1, 2, 3, 4. We are allowed to do 6 steps, right? So increase again. 1, 6. Okay. 1, 2. I have done 5 operations. I am allowed to do 6 operations because K is 6 here. So that will be 1, 7, 6, 5, 1. Okay. So after 6 operation, what will be the maximum possible value of my array? That will be 7. Okay. So the question is clear now. Okay. So let's think of an approach. Any approach you can think that can we achieve the solution? How we can achieve the solution with n equals 10 power 3. As n equals to 10 power 3, we can do big of n square or big of n square log n or big, any approach that will be greater than big of x square. Okay, so let's find out what should we do. Okay. So here, uh, one thing we can see that every element, every AI have its limits, right? Every AI can go up to a limited number. Right? What I am meaning by limited number. So in case of this problem, if I analyze, so we initially we don't have this data, right? We have calculated this what we are including. So the condition given here, it is clearly mentioning that we cannot change the last element, right? So what will be the second maximum possible second last element? So my maximum possible second last element can be either the existing element, or it will be 1 plus 1, that will be 2, right? Is it clear? Okay. Plus in case of here it is already greater than 2, so it will be my second last element, and it cannot be increased, right? So for the third last element, what will be its maximum value? So its maximum value will be 5 plus 1, that will be 6, right? Because we cannot, because 5 is fixed, okay? So we cannot go beyond 6, because the condition will be false if this is 6, this is 5, right? Uh, by this condition, you can check. So this will be 5, this will be 6, this will be 7, this will be 8. So in case of k here will be a large value, then also the maximum answer will be 8. No, nothing more than that. So I can confidently say that my answer lies between the already maximum element in the array and the calculation I have actually made. In my calculation, 8 is the uh, maximum possible value that could be achieved by AI, or the minimum value will be the already. So in this case, if I have any k, then what can I say? That my lower limit. So I will say that will be minimum result. My minimum result will be what? My minimum result will be the maximum value of the element. Maximum value of the array. And what will be the maximum result? That will be what? 5, 6, 7, 8. That will be 8. So at max, I can increase AI to 8, and for minimum, uh, so in this case, my minimum answer will be 5 and the maximum answer will be 8. That I can assure. Okay. Then what? Then we need to find out the actual result. Uh, the actual result, uh, we do k operation, right? That we need to find out. So what can we do? So here we can see that we have a limitation of my answer, possible answer, right? Range will be my possible answers range. My possible answer range is from 5 to 8. And if we can notice here that with the increase of number k, this result will be increasing, right? So we can use binary search here. So for any k, if any of the value between 5 and 8 is satisfying that, that means what? That means that can be our possible answer, and we can check uh, greater than that. So I will explain. So we are understanding that it is a Here we can use binary search, and okay, that is fine. So we need to calculate what will be the maximum value, and here we can use binary search because this condition is validating for binary search. And now what is the main thing is that how could we know that if uh, how can I check that with my so what I am setting. So let's write the code of binary search first, then I will check that what function inside binary search we need to think about that also. So let's code what I have think of. So the lower value can be, so I will take this left and right element and take it anything possible. So in that case, what will be by minimum value? That will be this. So this is my function that I have already defined. This function will return the mm, minimum value of the error. So here I don't need minimum value, I need maximum value. I also have this in my template. You can, so it is nothing but this is returning that what is the maximum value currently in my error. So what will be my R? So first of all initialize it will R equals 0. Then what I need to do that mm, I need to traverse from last. So why I am doing that? So in this case, let me write. So what is the maximum possible value for last element? That will be 1, right? Then what is the maximum possible value from this element? That will be maximum of 5 and 2. That will be what? That will be, sorry, that will be, that will be 5, 5. Okay. In case of this, what will be the maximum value? The maximum value can be 5 plus 1, 6, and maximum of 4, so that will be 6. Maximum value will be 6. What is the maximum value of this? That will be maximum of 3 and 6 plus 1, that will be 7. So 7, 7. Okay. So what is the maximum value for this element? That will be maximum of 1 and 7 plus 1, that will be 8. Okay. So what is the maximum possible value? That will be 8. So what I need to do that I need to traverse from M to start, and then I have to take maximum of AI and max plus 1. This is simple to do. Okay. So R will be max of R plus 1 comma 3 of I. I think that will be fine. So here there is a question that why I have initialized R from 0. You can initialize R from any negative number, any number less than equals to 0. Why less than equals 0? Because array the integers of the AI starts from 1. Okay. So even if I take 0, it will don't affect my uh, this logic. You can take any negative integer also if you doubt, but here it would not affect my logic because my AI is starting with 1. So 1 of 1 minimum it will be 1. So In any case, R will be minimum value possible from for R will be 1. So no problem with that. So okay, that is right that we have set it up the lower limit and the upper limit for our uh, binary search operation. Okay. Then what we need to do? Okay. So while loop up to when r equals l and okay need value. So if I need to make one function, so the function name will be is possible, anything we can give is possible. What will be the parameters? So let's think of it later. So if this is one of my possible answer, then I will be storing it in my answer variable or result variable, anything you can say. So my result variable will start with L because result cannot be less than L, right? And if it is possible, what happens that I will update my result equals need and I will search for higher values, right? For higher values I have to search, so I have to increase my lower limit. Okay. And for if this condition returns false, that means this will not this cannot provide me my answer, so I need to search for some lower value that if that value. So this is, so I am doing binary search on answer actually. So here we need to do that I have assumed some answer and then I will check that if this answer is possible or not. If so, I am here searching for the maximum possible answer, right? So for maximum possible answer, I will do that if it is possible, then we will search for more, right? And if it is not possible in some need, some point, then what I need to do that uh, I need to search for the left half, right? The smaller values. So I need to search for lower value, right? It is very and it is there is no problem to understand that. So why I am using binary search, is that clear? The binary search on answer is why I am using binary search on answer, because I have a limit and by increasing the value of k, my possible answer is also increasing. Right? That's why I am using binary search. So let's be very clear that if at some point I am getting answer 3, then any point greater than that point will also give me answer greater than equals to 3. That's why I am using binary search. So it is pretty much logically correct that here we can use binary search. So the next steps will be, so first of all, for doing a problem, we need to break up the problem into sub-problems. So I have first of break up my problem that it is a binary search and answer problem. Then I need to calculate this one, that if it is possible or not. So what parameter we need, that if so what I am getting with the value of need. So this is the possible answer, possible maximum value. Then I will check that with the value of k, can I reach maximum value of mid or not, right? That's why I need to create a function is possible. So let's create bool is possible. Uh, So what we should pass in this value? We need to pass of course need, so which will be my possible answer, and also k, the maximum operation I can do to uh, to, and then what I need to do that my array also I need. Then if I don't have array, then how can we can calculate? Okay, let's keep the order same. Any order you can pass. So that will be int int, and that will be int what I have taken int k, and that will be vector of I can see. Okay, one vector of int of a. Okay, so parameters are fine. So let's move on that if we can reach maximum value of need with k operation, okay, with at most k operations actually. So here I have already used log n operation, right? So we are allowed to do big of n square log n, right? Because 10 power 3 it is. So here I can also do a big of n square operation in this inside this function. I am completely allowed to do that because n is 1000. So no problem. So let's forget about that and let's try to figure out that what will be the maximum possible. Uh, so let's figure out that how we can check that if it is possible or not. So I have synced my problem into this problem. Okay. Let's check if it is possible or not. So what we need to do that we need to uh, we need to increase a AI value up to mid, right? Suppose my mid is 8 and my AI value is suppose 4. So what I need to do that I have to increase my value 4 to 8, right? So to do that operation, I need to uh, do lots of to do that stuff. I need to do lots of operations. So I need to calculate out that operations, number of operations. That how many operations do I need to do that thing, and then I can calculate that if it is less than number of operations is less than k, that means it is true, right? That means I can it is possible to do within k operations, right? Hmm. So for better understanding, let's move to this. So 1 3 4 5 1. Okay, 1 3 4 5 1. Uh, here I am. I have already analyzed that what will be the minimum result and what will be the maximum result. So write it down with L equals 5 and R equals what? R equals 5, 5, 6, 7, 8. R equals 8. Okay. So what will be my mid value? That will be 5 plus 8. That will be 13. That will be 6. Okay, no problem. Okay. So now let's check with 6 if any value can go up to 6. So let's check that what will be the maximum value of each of the elements. So that will be 8. So this is the maximum value that each element can go up to. So if I take index I equals, so I am here using zero base indexing. So I will be doing the logic with that. So in the index I equals 4, I cannot reach this value, right? In this index also, but in this index I can go up to n equals 6. So to do that operation, is the uh, what is the number of operation to do that? Okay. Uh, to reach from 4 to 6, how many operations I need to do? I need to do 2 operations. In case to reach 5 to 5, what we need to do? We need to do 0 operation. In case of 1 to 1, we need to do 0 operation, right? So what is the total operation we need? That we need 2 operations to reach up to 6. But here my k equals 6. That means we can reach 6 with less than equals value of k. So this answer is right. So next, what will be my r? So my r is changed to, so my result is stored 6. That means that I have updated my result to 6. So what will be my right value? So I will check for more values, right? So my left one will be that was 6. That will be mid plus 1. That will be 7. So what will be my mid value now? So my mid value will be 7 now. Okay. So let's check for 7. So for 7, so this could be 7. This could be 6. This can be 7. So um, for 7 that will be 3 plus 4. That I need 4 operations to move 3 to 4, and then 2 operations from 4 to 6, and then 0 operations from 1 to 1. That will be 4 plus 2, that will be 6 operations. So to reach m equals to 7, I need 6 operations, and that number of operations is less than equals to k. So this answer is also acceptable. 7 is also acceptable, right? So then I will search for 8. Then what happens? That I will search for 8, and 8 is only possible here. But to reach 8, what I need to do? How many operations I need to do? I need to do 8 minus 1, that will be 7. 7 minus 3, that will be how much? 4, and that will be 2, that will be 0, that will be 0, right? That will be 7, 4 to 4 to 6, 6 and 7, 13. That is mean 13 operation, which is the greater than k. So this is not possible. So my answer will be 7. Here you can say that it is 7. So that is the problem. That's how you can calculate out that if it is possible or not. But there can be multiple values. So what I am actually doing, that I am checking for some value that this point can go up to value mid, right? So then what happens, that is previous value must be uh, mid minus 1, and that previous value also will be what, mid minus 2, and keep going on. So if some value is greater than mid minus 1 or mid minus I, any value, that will be what? So in this case we will stop there, right? So in this case, that is here, we need to stop here because we cannot go beyond that. This will be okay. So let's move to the problem, that if it is possible or not. So from where we need to iterate, we can iterate from any starting value or any value. You can start from either I equals to 0 or I equals to any one you can take. So here I am starting from the first value, that if it is possible or not. Then what happens, that we will pick up one value I equals 0. Then I need to calculate how much value it needs to go upward. So here we need to apply same logic we have applied here. So we cannot start from I equals 0. So to apply the same logic, we have to rewrite the same thing there also. That okay, okay, yeah, it is fine. So what happens that if here I am making it something different, that will be uh, max value, so mx. So if mx is greater equal mid, that means what? That means this position I is a potential candidate that can be increased up to mid, right? So that's it is stating. So what I need to do, that I need to try to increase this A of I element up to max element, up to mid element, right? And then calculate if it is possible or not. Okay, if this is right, then int uh, operations 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 will be initially 0, right? uh, then I need to check for right ones, right? Because left one don't affect me. I need to check for only right one, if that is so. I have to start from is equals I, and then they will no need for it. I can use also while equals I and while less than n, and uh, okay, that is fine. If j less than n, then what I need to check, that what I need to do, that I need to increase the value of my current element. So my operations will be increased to a sorry. So I need to also calculate for, so if suppose I have a value, I want a value of 5 here, right? So its previous element must be uh, minimum, its previous element minimum that can be 4, right? It should minimum be 4 to increase this element to 5, right? And this previous element can will be 4 minus 1, that will be 2, 3, that will, this previous element will be 1, 2, and this previous will be 1, right? So in this manner I need to check if some value is already greater than this, that means we need to ignore to change that element. So I will stop here. Okay. Mm, so then what I need to do, that I need to also carry another integer that will be increasing increment, that will be 0 initially, and if operations if a of uh, j, if a of j hmm, if a of mx minus j, that will be greater than 12, that will be greater than a of j, then only we will do our operation. If that is true, then what will be my minus operations, that will be right, and then I will use my value also, that is right. Okay, operations. After completing the while loop, if my operation is less than equals k, that means it is 2, and if this that is not, if any of the value not satisfying that means it is false. What happens? Okay, I think that is fine. Let's check. Let's check if it contains some bulk, then we need to fix that also. What happens? I equals n minus 1 line number and 1 fifth. Okay, oh, it is not mentioned here. So I need to mention n also, that will be the of size. Oh, we need to return it also. See how. Let's check if it is 4 6 179 696. So it is giving wrong. Let's check if our limits are right or wrong. So let's print out what will be the left and right value. It is 3558 fine, 179 18 fine, 2 2 2 3 4 5 6, that is also fine, 5 6 7 8 9, that is also fine, 5 6, that is also left right is giving the right answer. No problem in that. So let's check with only one test case. Why it is wrong? What is the mistake that I have done? It is giving 6 but expected is 7. Let's check the mid value it is going to. First of all, it is going to 6. This is giving right answer, so it is storing 6. Then it is goes to 7. But in case of 7, it returns that 7 is false. The problem is in the is possible function. It takes 7, So let's try it. It takes 7, 6, and 8. Okay. So it is moving from right to left. Okay. Hmm. Okay. Max will be max plus 1 and array of 5, that is fine. And max is certain equals to that is a potential array of I. Okay, that is fine. Our since it is 0 initially is equals to I, then it to increase. mm, we need to increase J also. I have forgotten to do that. Right. 47179 4 6. What happened there? So I need to check the numbers. What is my logical mistake is that maximum value that will be 7. Uh, okay. 4 6. Let's check. That one. What is happening? Why it is giving 6? That will be 7 and it is getting wrong. 7 it is coming up here, then it is going to here, that this is the potential candidate for 7 or not. So that is not a candidate for 7, that is 6. And this is 7, right? So that is 7, potential candidate for 7. 7 minus 4, that will be 3. And then 1. Oh, okay, okay. Actually, I need to calculate from mid, not from max. Okay, so here I have done a mistake. Actually, max value for this that will be very high. What will be that? So 5, 6, 7, 8, 9. So I'm starting from 9, but what I need that I don't need 9, I need maximum of mid value. So that is confirming that max is possible. So maximum, so current element can go up to max, right? But we don't need to go up to max, right? We need to only calculate for need, but I am taking here max. So that will be need. So e minus increment greater than a of k. So I think that will work. That will not fine. So that is fine. I think that there is some mistake actually. Logically that I have done. 47179 576. Uh, yeah, that is fine. Here submit it. Yeah, it is accepted. And then before it, before taking the video. So yeah, that's for today. Like, share, subscribe.